Somewhere in the constellation Aquarius, astronomers aimed two of the most powerful telescopes on the planet, SOAR in Chile and Keck in Hawaii, at a single point in the sky. They knew something was there. The math demanded it, a companion object orbiting a spinning stellar corpse. But when the images came back, there was nothing. No glow, no glimmer, no faint smudge of light. The object was simply invisible, and that emptiness was the clue that cracked the whole case open. The reason they saw nothing turned out to be one of the strangest in modern astronomy. The companion wasn't missing. It was too cold to shine. Cold enough that its carbon had crystallized. The astronomers had photographed a diamond, roughly the size of Earth, and it was so dark it left no mark on the film. To understand what happened, you have to start with the neighborhood. This system sits about 900 light years from Earth in the direction of Aquarius. Later, more precise measurements pinned it down to 267.3 parsecs, about 871 light years away. At its heart is a pulsar named PSR J2222-0137. A pulsar is the collapsed remnant of a massive star, a spinning ball of impossibly dense material that sweeps beams of radio waves across space like a lighthouse. This one spins 30 times every single second. Every time its beam crosses Earth, our telescopes register a tick, a metronome so precise it lets astronomers measure things they could never see directly. The pulsar was first detected back in 2007 by a then graduate student named Jason Boyles using the Green Bank telescope in West Virginia. Boyles clocked its spin rate and noticed something in the timing of those radio ticks. The pulsar wasn't alone. Its beat was being tugged and delayed by the gravity of an unseen companion. By tracking the tiny variations in the pulsar's clockwork, astronomers reconstructed the invisible partner's orbit. It circled the pulsar every 2.4 days, and it was heavy, roughly as massive as our own sun. The numbers came out to about 1.2 solar masses for the pulsar and about 1.05 solar masses for the companion. The shape of that orbit told its own story. It was nearly a perfect circle, which suggested the system had never been violently disrupted by a second supernova. Everything pointed to the companion being a white dwarf, the cooling ember left behind when a sun-like star runs out of fuel. So the astronomers did the obvious thing. They went looking for it with visible light telescopes. This is where the story turns. When they pointed SOAR and Keck at the system, they should have seen the white dwarf easily. In fact, the image they captured should have revealed a companion 100 times fainter than any other known pulsar orbiting white dwarf, and about 10 times fainter than any white dwarf ever recorded. Even at that extreme sensitivity, they saw absolutely nothing. That non-detection was the answer. For the star to hide so completely, it had to be colder than 3,000 Kelvin, which would make it one of the coldest white dwarfs ever found. Described another way, it's burning at only about 4,892 degrees Fahrenheit, roughly 5,000 times cooler than the center of our sun. And at that low a temperature, physics predicts something remarkable. The carbon inside the star would no longer stay a chaotic fluid. It would settle, lock into place, and crystallize into a diamond-like structure. An Earth-sized gem forged not by pressure alone, but by 11 billion years of patient cooling in the dark. The discovery reframed how astronomers think about the oldest, faintest objects in the galaxy. Here was a star so ancient, it had cooled past the point of visibility, detectable only because it perturbed the ticking of its pulsar partner. Its invisibility wasn't a failure of the telescopes, it was the measurement. And it turned out this diamond wasn't a one-off cosmic freak. Around the same era of discovery, astronomers were finding carbon worlds elsewhere, objects where the chemistry of diamond and graphite seemed to be shaping entire planets. The Aquarius white dwarf had company. Take PSR J2222-0137, found by a team led by Professor Matthew Bales at Swinburne University of Technology. It orbits a millisecond pulsar that spins once every 5.4 milliseconds, more than 10,000 times a minute, a neutron star packing more mass than the sun into a sphere just 20 kilometers across. That planet whips around its pulsar in just over 2 hours at a distance of about 600,000 kilometers. It's roughly 60,000 kilometers across, 5 times Earth's diameter, with a mass close to Jupiter's and an astonishing density of about 23 grams per cubic centimeter compared to Earth's just over 5. Astronomers believe it's the stripped, crystallized carbon-oxygen core of a former white dwarf that lost more than 99.9% of its mass to the pulsar's gravity. Then there's 55 Cancri e, a planet closer to home in size but no less strange, announced in 2004 by a team led by Barbara MacArthur using the Hobby Eberly telescope. It's about 8 Earth masses and roughly twice Earth's diameter. It races around its star in under 18 hours, a true period of just 0.7365 days. After an earlier estimate of a 2.8-day orbit was shown to be a false signal by researchers Rebecca Dawson and Daniel Fabricki in 2010. In 2012, a paper proposed that this planet was built mainly of carbon in diamond and graphite form. In one model, roughly a third of its entire mass as carbon, much of it possibly diamond thanks to the crushing heat and pressure inside. Its dayside broils at over 2,000 Kelvin with a Spitzer average near 2,700 and a 2022 reanalysis suggesting it could reach 3,770 Kelvin. But the diamond planet idea for 55 Cancri e comes with a caveat. In 2024, observations from the James Webb Space Telescope ruled out the simple lava world with vaporized rock picture and instead found evidence of a thick carbon dioxide and carbon monoxide rich atmosphere. The story is still being rewritten as better instruments arrive. That uncertainty is the point. Some of these diamond worlds, like 55 Cancri e, remain debated and may look very different as the data improves, but the crystallized white dwarf orbiting PSR J2222-0137 stands as one of the eeriest objects we know of. A diamond the size of a planet, 11 billion years old, so cold and so dark that our proof it exists is the fact that we cannot see it at all.